Hey everyone, let's do some practice for the final exam. Just remember that the other study guides are also a good resource to study and any of our quizzes that we've done. All right, let's look at the first problem. Suppose a plumber charges a fixed rate for a service call and a rate per hour of labor. Here's data, and we want to use the table to write the linear function c of x equals mx plus b that models the cost for x number of hours. Now, if we remember, our b is our intercept. Our b is going to correspond to where x is 0. So our b is going to be 40. Then our slope. We remember our slope formula going to be y2 minus y1 over x2 minus x1. And let's use this next point here, 2 hours, cost of 70. So our y2 would be 70, y1's 40, x2, 2, x1, 0. That we end up getting 30 over 2 or 15. Okay, so we've got our b and our m. Now we have our function c of x equals mx plus b or 15x plus 40. If we want to evaluate c of 5, we will input 5 for x. And we get 115. So what does this mean? For an input of 5 hours, we have an output cost of $115. So that means that a service call that takes 5 hours will cost $115. Let's solve the inequality. 5 is greater than 3 minus x is greater than or equal to -1. So if we want to get x in the middle all by itself with a positive 1 coefficient. So first we'll subtract 3 from everywhere. And we get 2 is greater than negative x is greater than or equal to -4. Now, if we divide each part by -1, we're going to have a -2, an x, and a 4. But remember, when we divide by a negative number, our signs flip. So now we're going to have -2 is less than x is less than or equal to 4. And that is our interval notation. No, I'm sorry, that is not interval notation. That is our inequality notation. So interval notation would be from -2 to 4. We are not including -2, but we are including 4. Next question. Each day, a clothing factory has a fixed operating cost of $200 plus a labor cost of $85 per worker. We want to write a linear function, f of x, that describes the cost of operating the factory for one day, where x is the number of workers. Evaluate and interpret f of 10. Oh, sorry. So let's skip the function first. So we have an fixed operating cost of 200 and then $85 per worker. This is going to be our C, and this is our, I'm sorry, this is our B, and this is our M. So if f of x is mx plus b, it is going to be 85x plus 200. To evaluate f of 10, we'll plug that in. And we get 1050. So what does that mean? For an input of 10 workers, we have an output of a cost of $1,050. So if there are 10 workers, it costs $1,050 to operate the factory for one day. Find the number of workers X if the factory can have a daily budget of 2,000. So this 2,000, that means our f of X is going to equal 2,000, and we want to find X. So using our equation, our 85X plus 200, we'll set that equal to 2,000 and solve for X. Subtract 200 from either side. We get 85X equals 1,800. Divide each side by 85, and we get 21.18. So if we can't go over that budget, we have to have, we need to round down. So that means there would be 21 workers, excuse me. All right, next question. Let's find the following for the function whose graph is drawn, right, in A if not applicable. Okay, so first we want the domain. What X values does it take? Well, we're starting here at -3, and we're going all the way to positive infinity. And we are including -3, so we'll use that bracket. Okay, what is the range? So it looks like the range, we are here starting at -2, and we're going all the way down to negative infinity. And we are also including 2, so we'll put that in the bracket. So we have from negative infinity to 2. All right, what are the intervals of increase? So for increase, we're increasing from here. Let's call that vertex right there at -1. So we're going to be increasing from -3 to -1. And remember, we never include the endpoints on intervals of increasing or decreasing. Lastly, our decreasing, it is decreasing from -1 to infinity. Okay. Now, local max and mins. Now, we know we have a max up here at the top. Its location and value. It's located at -1 with a value of 2. And then we also have a local min down here. That one is at -3, -1. Okay, we do have an absolute max. That is our local max. But there is no absolute min. It keeps on going forever. Let's find the vertex of the formula. Use the vertex formula to find the vertex of the quadratic function. F of X equals -x squared minus 2x minus 5. So our vertex, if we remember, we call that HK. To find H, we take -b divided by 2a. Remember, this is our A, our B, and our C. So -b, b is -2, so -b would be +2. 2 times a is -1. So we get an h value of -1. To figure out our k, we use f of h, which is f of -1. When we plug that in, we have -1 squared minus 2 times -1 minus 5. Let's see, what do we get? Once we solve that out, we get -4. So our vertex is at -1, -4. A diver jumps from a rock into a lake 35 feet below. His trajectory is described by the function h of x equals -1.6 x squared. Let's say plus 4x. Yeah, let's call that plus 4x plus 35. Okay. What is, sorry. Okay, so we have the function h of x equals negative 1.6x squared plus 4x plus 35, where h of x is the height in feet and x is the number of seconds after he jumps. After how many seconds does a diver reach his maximum height? So we know by this formula that we have a downward opening parabola. So that maximum height is going to occur at the vertex. After how many seconds? That's finding our x, or our h, for the vertex. So again, we're just going to do our vertex formulas. H equals negative b over 2a. So we get negative 4 over 2 times negative 1.6. And we calculate that. We're going to get 1.25. So after 1.25 seconds, he reaches his maximum height. What is the maximum height of the dive? That's going to be our y value for the vertex, or our k. Our k is f of h. So we'll do f of 1.25. That's going to be negative 1.6 times 1.25 squared plus 4 times 1.25 plus 35. And we get value of 37.5. So he had a maximum height of 37.5 feet. Okay. We want to use the graph to solve the inequalities. For this first graph, where is f of x greater than 0? So it's greater than 0 everywhere to the right of 3 and everywhere to the left of negative 1. So we want to write that in interval notation. That would be from negative infinity to negative 1 union 3 to infinity. Okay, and where is g of x less than or equal to 0? We cross 0 right here, and so everywhere to the right. Cross 0 there at negative 4, everywhere to the right. So g of x is less than or equal to 0 from negative infinity to negative 4. We include that point, and from 0 to positive infinity. Let's use the quadratic formula to solve the equation x squared minus 2x minus 2. We want to write the answers in the form of a plus or minus bi. When we see this a plus or minus bi, we should think we're going to need to use the quadratic formula. First, we need to get it set up into our kind of standard form, where we have ax squared plus bx plus c equals 0. So that would become x squared minus 2x plus 2 equals 0. And we will use our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we get 2 plus or minus. We evaluate under the square root. We get negative 4, all divided by 2. The square root of negative 4, we pull that I out, and then take the square root of 4. So we left with 2i. And then if we split that up, it's 2 over 2 plus or minus 2 over 2i. Those are both just equal to 1. So we're left with 1 plus or minus I. Okay. All right, for the following graph, we'll identify the parent function and describe what transformations are applied. So our parent function, this is a quadratic. So our parent function, is y equals x squared. Okay, so we First of all, we know that it's flipping downward where our parent function flips upwards. So that is a reflection across the x-axis. And we have our vertex here at -2, +4. So we're going to have some shifts associated with that. We're going to shift left 2, and we'll shift up by 4. And those are all the transformations for this one. For the next one, we're just given a function, h of x equals negative square root of x plus 11 minus 2. So its parent function is just y equals square root of x. The negative sign out front is also going to indicate a reflection across the x-axis. The 11 underneath the square root is going to indicate a shift either left or right. This one's kind of backwards of how we might think. So that positive 11 means a shift to the left. And then the -2 out at the end is going to be a shift down. We want to write a polynomial in factored form with zeros of 2, -2, and 1. So what we need to do is we need to convert each of those zeros into factors. So that 0 of 2 becomes x minus 2. 0 of -2 becomes x plus 2. And the 0 of 1 becomes x minus 1. They each have a multiplicity of 1. So that each of these factors has a power of 1. And so this is our final answer. Okay. For the function f of x equals 2 times x plus 3 squared times x minus 4 cubed. We want to list their zeros and their multiplicities, and then would each zero be either a touch or a cross point. So we have a factor of x plus 3 corresponds to a 0 of x equals -3. That factor is squared, so it has a multiplicity of 2, and that means it would be a touch point. We have a factor of x minus 4 corresponding to a 0 of x equals 4. That factor is cubed, so it has a multiplicity of 3. Since that is an odd multiplicity, it will be a cross point. Remember, odd is cross, even is touch. We can do the same thing, but with a graph. And we're going to assume each 0 is an integer, and multiplicities are either 1, 2, or 3. So we'll write our zeros or multiplicities, and then we'll find that function. So we have a 0 here and here. So one of our zeros is at x equals 0. It's a cross point, so we know it's either going to be a multiplicity of 1 or 3. But it goes through fast. It doesn't take its time going through. It doesn't go through slow. So that's going to be a multiplicity of 1. Then we have this other 0 at x equals -2. It touches, so it's going to be a multiplicity of 2. Okay, we're almost there. We just need to figure out the lead coefficient. This parent function is like a y equals x cubed. The parent function rises to the right and falls to the left. Since this one does the opposite, it's going to have that coefficient of -1. So we know we're starting off with a negative. We have a 0 at x equals 0. We'll put that one first. And then we have a 0 at x equals -2, which corresponds to a factor of x plus 2. And we'll square it because of its multiplicity of 2. For each of these functions, rational functions, we are going to find any vertical asymptotes or any horizontal asymptotes. So for the first function, f of x equals 8 minus 4x divided by x plus 3. Our vertical asymptotes are where the denominator can equal 0. So all we need to do is set the denominator equal to 0 and solve for x. So we know we have a vertical asymptote at x equals -3. For the horizontal, we look at the degree of the polynomial for the numerator and the denominator. We call the degree on top n and the degree on the bottom m. And depending on how n and m are related, tells us what kind of horizontal asymptote we'll have, if any. So here we have a first degree polynomial on top and a first degree polynomial on the bottom. That means n equals m. And when that's the case, we take the division of the lead coefficients of each polynomial. So on top, that lead term is -4x. So that lead coefficient is -4. On the bottom, our lead term is 1. Our lead term is x. So that lead coefficient is 1. So we get a horizontal asymptote of y equals -4. For the next one, 1 divided by x minus 2 squared. So again, we'll set that denominator equal to 0. Here, we don't have to worry about the squared. It's not going to make any difference. So we know we have a vertical asymptote at 2. For the horizontal, here our numerator degree is less than our denominator degree. Whenever this happens, we always have a horizontal asymptote at y equals 0. And then last, we have 5x cubed divided by x squared minus 5x plus 4. So again, we'll set that bottom equal to 0 to find our vertical asymptotes. Here we need a factor. We know we're going to have an x, 2 factors like so. Here we have a +4 for our c, but a -5 for our b. That indicates that we're going to have 2 minus signs here. And then we need to look for 2 numbers that multiply together to give us c and add together to give us b. It's going to be 4 and 1. So these correspond to vertical asymptotes of x equals 4 and x equals 1. For the horizontal, we have a third degree polynomial on top and a second degree on the bottom. That means n is greater than m. And when this happens, there are no horizontal asymptotes. Let's solve the rational equation. X plus 6 divided by x plus 4 equals 5 over x. Here, we need to find the least common denominator and multiply our entire equation by it. A lot of the times, finding that least common denominator can be found by multiplying all denominators. And in this case, it does work. So our least common denominator is x times x plus 4. So we're going to multiply that by our entire equation. So if we do x times x plus 4 times x plus 6 over x plus 4, that equals 5 over x times x plus 4. Here, all of our denominators will cancel out since we got a appropriate least common denominator. And so we're left with x times x plus 6 equals 5 times x plus 4. Okay. Let's distribute. We're going to get x squared plus 6x equals 5x plus 20. All right, we see we have a quadratic, so we'll probably need to factor it to solve it. So let's get it in that standard form where it equals 0. So we have an x squared. We'll subtract 5x from either side. That leaves us with a positive x. And then if we subtract 20 from either side, we get a minus 20. Okay, now to factor this, We have a negative 20, so we know we're going to have one positive and one negative. We need the two numbers to multiply together to give us negative 20, add together to give us 1. So we know 5 and 4 can do this. Just what's the right order? We need that positive b, so that we need a positive 5 and a negative 4. And these correspond to solutions of x equals 4 and x equals negative 5. Number 6. For a given span, the maximum weight y that a wooden beam can support varies directly as the square of its height x. If a beam supporting a maximum weight of 4 tons has a height of 1 foot, find the constant proportionality k. What is the maximum weight that a beam of a height 1.5 feet can support? So first we need our generic formula. We know we have a weight y that varies directly as the square of x. So vary directly means that our variable is going to be in the numerator. So it's going to be y equals kx. And then we look, okay, is there any variation to x? And it's going to be the square. So this is our generic formula. And now based off of an input of 4 and 1, or based off of an input of 1 and an output of 4, we can find our k. So we'll plug those values in. It's going to be 4 equals k times 1 squared, or k equals 4. Okay, so that means our equation is y equals 4x squared. And if we want to find the maximum weight that a beam of a height of 1.5 feet can support, we're going to plug 1.5 into our equation. And we get 9. So this means that the maximum weight that it can support is 9 tons. Suppose the time t in hours to complete a project is inversely related to the number of workers W. So what is our equation? We have the time t inversely related, so that means that our variable W is going to be in the denominator. It doesn't look like there's anything that's happening to W. We're not going to square it or square root or anything like that. So we're going to have t equals k over W. Okay, so we're told that 3 workers can complete the project in 10 hours. So we can find k with that. So if it took 10 hours for 3 workers, that means our k is 30. So now we have our formula, t equals 30 over w. Now, how long would it take the project, the same project, how long would it take for 5 workers? So we just plug in for the number of workers. We get 6. So that means it would take 6 hours for 5 workers to complete the project. Okay, given 2 functions, we have f of x equals the square root of x minus 2 and g of x equals 2x plus 10. We want to evaluate and simplify these following functions. We've got g times f of 4. This is the same thing as g of 4 times f of 4, where g of 4 is 2x plus 10, so it's going to be 2 times 4 plus 10, and times f of 4. F of 4 is going to be square root of 4 minus 2. So once we evaluate this, we're going to get 14 times the square root of 2. And that's our answer. That's the most we can simplify it. Oh, I'm sorry. This should have been 18. It should be 18 square roots of 2. Excuse me. Okay. So now if we want to evaluate f composed with g of 4. So this is the same thing as saying f of g of 4. Now, we've already evaluated g of 4 right here. It is 18. So really, we're evaluating f of 18, which would be the square root of 18 minus 2, or the square root of 16, or just 4. Okay, let's find some inverse functions using the swap and solve method. So here we have g of x equals 5x plus 1 divided by 2. So the first step is to change it to y equals instead of g of x equals. So y equals 5x plus 1 divided by 2. Now we swap our x and y. So we get x equals 5y plus 1 divided by 2. Okay, now we want to solve for y. So let's multiply each side by 2 to get rid of that denominator. So we're going to have 2x equals 5y plus 1. Subtract 1 from either side. 2x minus 1 equals 5y. And then divide each side by 5. So this is our inverse function, but we just need to give it the proper name. So this is going to be inverse of g of x equals 2x minus 1 divided by 5. Now let's do the same thing for g of x equals x plus 2 cubed. So again, we're going to call that y equals x plus 2 cubed. And then we'll flip our variables. So we'll have x equals y plus 2 cubed. Now there's two things we can do to get rid of that cube. We either take the cube root of each side, or we raise each side to the 1/3 power. So we'll just do the cube root instead. So that means the cube root of x equals y plus 2, or the cube root of x, we subtract 2 from either side, equals y. So give it our inverse name. Inverse of g of x is the cube root of x minus 2. To find the domain of a logarithm, we set the argument greater than 0 and solve for x. So here we just have negative x plus 5, call that greater than 0. Here we can just add x to either side, and we get 5 is greater than x, or we want to put that in, normally we'd write it x is less than 5. So if we wrote that in interval notation, that would be from negative infinity to 5. Or if we wanted to do set builder notation, x such that x is less than 5. Okay. The number of jobs in a city is increasing each month. The number of jobs y after x number of months is displayed in the table. Let's find values for c and a to write the function f of x equals c times a to the x that models a given set of data. Okay, so this, our initial value, that's going to be our c, wherever x is 0. So we know we're going to start with a function that looks like f of x equals 3a to the x. And now we can use any one of our other points to figure out what a is. So let's use the point to 12. So we'll plug in 12 for f of x and 2 for x. Okay. All right, if we divide each side by 3, we're going to get 4 equals a squared. We take the square root of either side and get a equals 2. That means our function is 3 times 2 to the x. All right, if the trend continues, we can use the function to find the number of jobs after 8.5 months. So we'll just input 8.5 to our function. So 3 times 2 raised to the 8.5 power. And that comes out to 1086.12, which means that there would be 1,086 jobs. Let's write the logarithm as the sum and differences of logarithms with no exponents or radical. So when we start here, we always want to do that quotient property first. We want to get rid of that denominator. So this is going to be natural log of square root of x, y squared, minus natural log of e cubed. Okay. Then we can, with our natural log square root of x, y squared, we can split that up using the product property. It's going to be natural log of square root of x plus natural log of y squared. Now, at the end, we have this natural log of e cubed. One of our properties tells us that this is just equal to 3. When we have the same base of our log and base of the argument, then it's just equal to that power. Okay, now we don't want any exponents or radicals, so we're almost done. This natural log of square root of x is the same thing as natural log of x to the 1/2 power. Using the power property, we can bring that 1/2 out in front of the log. So this is going to be 1/2 natural log of x. And then we bring that power of 2 out front to get 2 natural log of y minus 3. And we are done with that one. For the next one, we want to combine them. Now, we can do this in multiple steps, or we can do this all in one step. So here we have log 4 plus log 5. That means we use that product property. We're going to have 4 times 5. And we have minus log 2 means divided by 2. This is log of 10. Now, using that same property that we use up here, where if we have the same base of our log as we do of our argument, then it's just going to be equal to that power. Well, here we have a log base 10 of 10. We can think of that raised to the 1 power. Oops, sorry. Oops. So that's just 1. That's another one of our properties that we learned. Now let's solve these logarithm equations and round to 2 decimal places. We have 5 natural log of x minus 2 equals 10. So we'll start by dividing each side by 5. We'll have natural log of x minus 2 equals 2. Now, we can convert this to an exponential. We have a log base of e. We raise that to the second power, and that will equal our argument. So this means that if we add 2 to either side, e squared plus 2 equals x. And if we plug that into our calculator, we get 9.39. Okay. Now we have log of x minus 2 plus 3 equals 5. So let's start by subtracting 3 from either side. We have log of x minus 2 equals 2. Okay, now we'll use that same, we'll convert it also to an exponential. We have a log base 10. So that raised to the second power equals our argument of x minus 2. If we add 2 to either side, we get that. 10 squared plus 2 equals x. 10 squared is 100, plus 2 is 102. That's our answer. Okay. If we invest $4,000 in a money market account at an annual interest rate of 6% compounded continuously, we want to find the number of years t needed for the amount to grow to a future amount of 10,000. So let's figure out what we have so far. We invest $4,000. That's our initial or principal amount. We have an interest rate of 6% or 0.06. We have a future amount of 10,000, and we're trying to figure out what's our T. So using our equation, A equals PE to the RT, fill in what we know. So that gives us 10,000 equals 4,000 E to the RT. And now we want to solve for T. Okay, so divide each side by 4,000. It's going to be E to the 0.06T. Now, we can convert this to our logarithm form. We have that exponential. We want to convert to the logarithmic form. So that is going to be so we have a base E here. And so that's going to be the natural log of 10,000 over 4,000 equals 0.06 T. The other way that I like to think of it is just take the natural log of each side. So if we take the natural log here and natural log here, that natural log and that E just kind of cancel out. Okay, so now if we divide each side by 0.06, that is natural log of 10,000 divided by 4,000 divided by 0.06. And it'll be equal to T. So when we plug that into our calculator, we get T is 15.27. Round to the nearest year. So it would take 15 years to grow that initial investment to $10,000. Okay, let's solve this system of equations. We have 2x plus 5y equals 2, and 3x minus 2y equals 3. So we've already got those y's in ones plus, ones minus. Let's use the addition method to solve this. We don't have any x or y's by themselves, so it might be easier to do this than using the substitution method. So let's get those coefficients on the y's the same. Let's make both coefficient 10. That means we're going to multiply this first equation by 2 and the second equation by 5. So that's going to give us 4x plus 10y equals 4, and 15x minus 10y equals 15. Now let's add those two equations together to get rid of those y's. We're going to end up with 19x equals 19, or x equals 1. Now we want to plug that back in to either one of our equations. It doesn't matter which one. Let's just do the top one, 2x plus 5y equals 2. So 2 times 1 plus 5y equals 2. If we subtract each side by 2, we're going to get 5y equals 0, or y equals 0. So our solution is 1, 0. Okay. The combined number of COVID cases in California and Texas was 20.6 in millions. California had 3.6 million more cases than Texas. Let's write a system of equations and solve to find the number of cases for each state. So first, define your variables. Let's call x is the number of COVID cases in California. And y is the number of COVID cases in Texas. Okay. We know that if we add up both California and Texas, that there's going to be a total of 20.6 million. So that corresponds to the equation x plus y equals 20.6. We know that California had 3.6 million more than Texas. So if we take, so California is Texas plus 3.6. California had more, so we need to add that number to Texas. Okay, now we have our two equations. We can solve them. We already have one set up for x equals y plus 3x, so I suggest we use substitution method. So if we take our x plus y equals 20.x, and we plug in our new value for x, it's going to be y plus 3.6 plus y equals 20.6. That's 2y plus 3.6 equals 20.6. Subtract 3.6 from either side, and we get 17. Divide each side by 2, and we get 8.5. Okay, so using our x equals y plus 3.6, we'll plug in our value for y. So x equals 8.5 plus 3.6, or x equals 12.1. And so what does this mean? This means that California had 12.1 million COVID cases, and Texas had 8.5. Okay. Let's use the addition method to solve this system of three equations. Y minus z equals 2, minus x plus y plus z equals 9, and x minus y equals negative 6. So we need to look and see, is it already set up where anything can be crossed out easily if we just add it as is? So we have a negative x and an x, those will cancel out. We have a negative z and a positive z, those will cancel out. So we can just add them right away. We have our y minus z equals 2. We have a minus x plus y plus z equals 9. And x minus y equals negative 6. And so we can just add all three equations at once. Those x's cancel out and the z's cancel out. So we have y plus y minus y. That's going to be a positive y. And then 2 plus 9 minus 6 is going to be 5. Okay. Now we can easily figure out the other two. We have y minus z equals 2. Plug in our value of 5. So 5 minus z equals 2, or minus z equals minus 3, or z equals 3. And then we also have x minus y equals negative 6. So x minus 5 equals negative 6, or x equals negative 1. So our solution, xyz, is negative 1, 5, 3. Okay. Let's perform the following row operation and then write the new augmented matrix. So we're going to do 5 times row 1 plus row 3 to become our new row 3. So let's figure out what is 5 times row 1. Well, we just multiply each one of those values by 5. This is going to be 5, 2, -1. Oh, sorry, I messed all that up. Let's try this again. It's going to be 5, 10, -5, and 15. Okay. Our R3 is not going to change. It's going to be -5, 2, 5, and 1. So if we add those together, you're going to get 0, 12, 0, and 16. And that is our new R3. So to write our new augmented matrix, we are going to keep the first two rows the same. But we're going to change our row 3. And this is our new augmented matrix with that row operation. Okay. For the following given matrices, evaluate each of the following. So first we have 3c minus 2d. So let's figure out what is 3c. We just multiply each element of the matrix by 3. 21, 3, -6, and 12. Similarly, 2d is going to be 4, -8, 8, and 6. Oops, sorry about that. And 6. So to add the two, 3c plus 2d. We just add each element, each respective element. So the first one is going to be 21 plus 4, 25. Let's see. Oh, I'm sorry. This is supposed to be a minus. So really we want 3c minus 2d. So it's going to be 21 minus 4 is 17. We're going to have 3 minus a -8, which will be 11. We have -6 minus 8, or minus 14, and 12 minus 6, or 6. And that is our final answer there. And then for 2c plus d. So our 2c is going to be 4, -8, 8, and 6. Oh, that's 2d. Sorry. I'm just messing up here. Okay, let's try this again. 2c is going to be 14, 2, -4, 8. And d is just going to stay the same. Okay, so now we want 2c plus d. Just add those elements. So it's going to be 14 plus 2, 16. 2 plus -4 is going to be, let's see, would be a -2. A -4 plus 4 is going to be 0. And then 8 plus 3 is 11.